Hi folks, it's Dave with Dragonfly Engineering. So today we've got a quick fixture to make. I need to grind 12 of these ejector pins, and I didn't want to do them one at a time. I did make a fixture in a previous episode, which was an EDM'd V-block. Let me grab that block. Yeah, so in a previous episode I modified this off-the-shelf V-block by EDM cutting this ejector pin recess in the bottom. You can see that right there. And that is for larger ejector pins. So this fixture I made using the EDM machine, and you can see how I EDM'd out of pocket so that the foot would fit, and then we could stick this whole thing onto the mag chuck of the surface grinder and then cut and grind our pin to length. But this larger fixture doesn't really work for these small ejector pins. So what I need to do, and I've got a bunch of these ejector pins to grind for a customer, for a day job here. So what I need to do is make a fixture that will hold a bunch of these ejector pins to the same height and clamp force, and then load the entire fixture into the grinder and then grind all the ejector pins off at the same time. I could show you the model or the CAD, or actually the CAM on the computer here in a second, but for now what we're going to do is I've got two aluminum plates, and the aluminum plates are going to have a bottom groove, several bottom grooves to mount the ejector pin in different heights, because all these ejector pins usually they vary in heights depending on the mold cavity, and they also vary in diameter depending on where you can fit ejector pins into the cavity of your mold. So the plan is to use a piece of stock aluminum like this, and we're going to machine a couple of grooves in the bottom so that the foot of the ejector pin will fit. And then we're also going to machine a whole array of small V grooves along the orthogonal axis to the bottom foot clearance. That way we can clamp a whole bunch of ejector pins into the same fixture at the same time, and I can save a lot of time by grinding all of the pins. So we can go ahead and load this guy in. I've got two vices, actually three vices on this Haas tool room mill. And a lot of times I'll use one vise basically to clamp a piece of scrap to use it as a stop for your actual work that you're working on. So this is a little bit easier than the little jaw clamp, because this scrap is below the surface of the plane that I'm going to be cutting the top of this aluminum off. All right, so let's go ahead and clamp this guy down. I usually like to tap these things in place so that our parallels are tight. That tells us that the stock is square and flat on the bottom reference of the Kurt vise here. And I'll go ahead and start facing this off. So I'll turn the spindle on, and I'm going to be doing jogging here. So I'm going to move the tool, the wobbling tool, over until the shaft gets aligned and then kicks out offset, which tells us that we're rubbing on the edge. This fixture is not critical, so I'm not going to waste too much time on it. Pull out a Z, part 0 set, and then I'm going to jog over by half the width of our edge finder, which is 0.1 inches. Or 2.54 millimeters. I'm going to go back to offset and then part 0 set again. And then we'll do the same thing for Y. And I have a little bit of the edge of the vise here that I can pick up. Okay, so you can see how it's just kicking off a little bit there as I sneak up on the edge. And then we repeat the process. So I moved up in Z. I'll tell it part 0 set. But then you always want to remember to take half the width of the wobbler off. I received a few parts that are always 0.1 inch off because whoever did it forgot to offset their wobbler. Okay, so part 0 set. If your mill will allow you to get close, with the safety interlocks and stuff, then I just look at the reflection of the tool and the surface of the metal that you just cut, And it's actually twice as accurate because the reflected gap is twice as big as the actual gap that you see. So this may not be the best technique for everyone, but this is what I've evolved to doing. And I can, with the right loop, this is a 10x, I think, you can see a couple of microns of tool offset, which is just about as good as probing systems. Okay, so under the tool offset, I am going to set this tool height and then tell it next tool. Now I need to get a chamfer tool, so a 90-degree tipped end mill. So I may pause the video for a second. Yeah, so I'll be right back with the tool that we're going to use. Okay, I'm back. So here's the chamfer tool that we're going to use. Let's see if we can zoom in on it. It's a 3/16 diameter, or 4.8 millimeter, with a, what is that? It looks like it's actually not 40 degrees. It looks like a 60-degree angle on the tip. And the tip goes down to a nice clean point. There's no flutes on this, but there are two cutting edges, kind of like a chamfering tool. I get my little loop. Loop means eyeglass thing. And we'll come down. And this dimension isn't too critical. So that looks good. Offset. Okay, so I think we're ready to load the program and run it. So I'll be right back. All right, so here's the program, or the sketch and the CAM program. And the first operation is to machine the clearance slots for the feet of the ejector pin. And we've got 3 lines here that we're going to mill down the middle to create our 3 clearance slots. This is so we can adjust the height of the ejector pins. The next thing is we're going to cut this V-groove. So we're going to hit this line, and then we want to have 12 of these going across. So I'm going to save this. And then we're going to do an array of this cut that's highlighted right now. And we're going to do minus 10 millimeters. I apologize for the inch people, but I typically work in millimeters. So sorry. Okay, so we're going to array this cut by minus 10 millimeters 12 times. And there we go. Okay, and then F3 to load it. And it's reading in the file. And then I like to back the tool off the stock. And it's also a good idea to double check your 0. So I'm going to tell it to go to 0, X0, Y0. You can also say G0, X0, Y0. Okay, we are at the stock corner, which equals that on the program. So we're going to go to menu, and we will tell it to cycle start. I get the coolant ready. I'm a little low on the coolant. I'm going to reduce the rapid. And the first thing it's going to do is change the tool so I can increase the rapid. And I'm ready on the reset. Now I'm going to be ready on the feed hold. In fact, you can hit feed hold or cycle start to start and stop the program. But I'm going to be hitting cycle start. Actually, let me turn the coolant on. Okay, and then we'll hit cycle start, and I'll be on the feed hold if I don't like what I'm seeing. Okay, there we go, and we're cutting. So we'll hang out here and make sure everything is good. I might add some coolant. And then when we switch to the V-groove cut, then I can walk away. I've already found an issue. I'm probably going to machine into the vice jaw a little bit there. Okay, so I need to offset the stock up for this cut. Probably get the next parallel. And fortunately, our edge, our work stop is still going to work because its height overlaps. So let me stop and fix this. Well, let me double check. Yeah, we need to bump up the stock a little bit and then reset the tool height. All right, so let me reset up, and then we can do this final cut. So this is the V-groove that's going to hold the shaft of the ejector pin, and we can hold it in 3 different positions in height for our surface grinding operation, which we're going to do next. So once it steps over in the program, then I'll know we're good to go, and I'll probably do a time lapse after this. But yeah, there's our 12-way quasi-universal ejector pin grinding fixture base. 12 V-grooves and 3 landings for different heights of ejector pins. All right, so let me go ahead and stick the 4 threaded holes in the corner so we can make this fixturing easier, and then I will swap this guy out for the top plate, which will be simpler. We're just going to do the 3 reference grooves at the bottom. And this is a drilled hole for a tap, so the depth is not critical, so I'm just going to look at it. That looks good. So we'll offset the tool for the drilling. And then the next is we're going to set up for the tap. And I need a collet holder for that. And then we just stick our M4 tap in. And I just give it a decent tension here. Okay, that's it. All right, so let's stick this M4 tap into tool position 5. I am going to eyeball this one as well. So the drill pecking operation is what's happening right now, and basically the mill pulls the drill bit out to clear out the flutes, and that's done with the rapid motion. So you can, to save yourself a lot of time, you want to increase the rapid for drill operations, at least for the Haas and the Herco. If you just try to drive that drill bit in without pecking and clearing the flutes, then it'll break about probably 1/2 inch to 3/4 of an inch in. So it may not break in this operation, but it also reduces the life of the tool because you're jamming up aluminum chips and it turns into kind of a cake of aluminum in the flutes of your drill bit. So it increases the diameter of your hole, it reduces the life of the tool, and it'll probably break off if you try to drill too deep without drill pecking. All right, so now we're going to do our tap operation. This is rigid tapping, so the spindle is synchronized with the Z-axis. You see how it stopped and then kind of kicked into its rigid tap mode? And then when it's hit the bottom, the spindle spins the opposite direction and synchronizes with the Z-axis travel to match the helix of your tap. It's good to blow out your first tap to make sure there's actually threads there. Okay, we'll load our second stock in. But I'm not quite sure about everything, so I'm going to be a little extra careful here. Coolant. Let me check the parallels that they're, no, that one's not pinched. We're going to reset. I got to hammer this part in a little better. I skipped that. All right, now the parallels are happy. Okay, menu, cycle start. And I got my hand on the feed hold just in case. But so we don't have to always fuss about rewriting programs for new parts. You can just select chunks of your previous programs. But I got to make sure I stop before the tool change, stop after this first tool is done, because we don't want to cut grooves. Because I think some of the smaller tools won't fit in the one-sided grooves that I've made if I cut those grooves on this side. All right, I'll be back. Enjoy the time lapse. All right, so this is an M4 counterbore tool. Can you see that? And basically, there's a pilot hole for the clearance hole for an M4 thread. And then this is the socket cap head counterbore profile. This saves you having to do the fuss of doing an additional CNC setup when all you really need to do is just punch some countersinks on the back. So let's go ahead and start that, and it cuts pretty good and quick. Not too many forces. It doesn't like bite like a drill does when it breaks through. So it's a more controlled cut. I think I bought this on McMaster Car. All right, so the use of this ejector pin grinding fixture is to reference our pins and pick up 3 different heights that we want. Because usually with these injection molds, I've got to, there it is, grind or rough cut. Like for instance here, I've marked this blue line is where I'm going to cut off this excess of the ejector pin length with the die grinding or cutoff wheel. And I'll cut 12 of those, and then I'm going to load all of these pins into whichever position looks to be the best. In this case, I probably should have made this fixture a little taller. So here's our blue mark. So we're going to reference the bottom edge, and then I will, after I cut all these roughly with the die grinder, then we can load all these ejector pins in, and I can surface grind them all to the exact height at the same time, up to 12 across here. I guess I should probably have one down here. Well, I'm going to do all 12, but if I had less than 12, then I'd have to strategically mount these guys such that our top plate, which is like this, and this is the clearance grooves for the tops of the feet on the ejector pin, work like that. And then I would screw these guys in, and then here's all of our pins ready to be surface ground, and I can push them down and then clamp it. So they're all referencing the offset bottom to the vise. So the vise will sit on top of the mag chuck on the surface grinder. So that's it. So let me cut these guys to length. All right, so every spot gets a pin. Again, this is a universal fixture, so these V-grooves are intentionally shallow so that I can cover a large range of ejector pins and mass grind all of these at the same time, which will save me a lot of fuss over the previous tool that I showed you. So now we can do 12 at a time, 12 smaller ejector pins. So yeah, unless I get crap in it. Okay, and then we put the cover on. The only way to be sure that you've got the right Allen key is to have the kit, at least in my shop, because I've got thousands of Allen keys that are loose and in the wild. All right, so now that I've snugged the screws down, I can tap on all the tops of these ejector pins that I just rough cut with the grinding wheel. Let's see if you can see those. Yeah, so these are just basically die grinder cutoff wheel cut. They all feel like they're snugged in. So now we can tighten these guys down, and we're relying on the rigidity of this aluminum, these 2 aluminum plates to hold the center guys down, which may be questionable. Yeah, they feel loose. All right, I'm going to have to add another threaded hole down the middle of this for both of them. I'll probably just do that on the drill press, because right now I'm imparting a bow. Even though this is thick aluminum, these pins in the middle are loose, but the ones on the ends are tight. So let's go ahead and get our 2 holes in. This RPM is probably a little low, but that's okay. All right, that should do it for that. Kind of have a green marker spot there, but it's more of trying to bisect the gap between the 2 pins. This definitely isn't for sale now. So this is a counter bore for our socket cap head M4 screws. And this is the counter boring tool that we looked at earlier. All right, I got you over at the surface grinder. We're going to load a new Kurt 4-inch vise onto the mag chuck here, and to do that I got to remove this kind of drip guard. Okay, so I've already wiped down the mag chuck with some WD-40 to clean it off real good, and the bottom of this Kurt vise. You saw in previous grinding episodes, I was always complaining about a toolmaker's vise and it would lose its grip a lot, or its clamping, because it was kind of just one angled screw. So I went ahead and got this 4-inch Kurt vise, which definitely will hold stock. In fact, I even lost a run on using the toolmaker's vise because in the EDM machine, because the clamping force gave way and the EDM machine sucked the part it was EDMing out of the vise, which kind of sucked. Excuse the pun. All right, I'm moving this vise over so I can access the mag chuck activation key. So we're going to turn the magnet on by spinning this key. And now the Kurt vise should be in place. I'm rotating the vise perpendicular because I'd like to do a single run of grinding of our pins. I got the garage door open, so this is the best angle for lighting. Okay. So that's pretty close. We go ahead and clamp our aluminum fixture in. No one sponsors me, by the way, so me touting Kurt vise is just, this is the one I bought to replace the pretty nasty vise that I was using. But if they'd like to sponsor me. All right, so I don't have the stone on right now. I'm just checking rough heights. So this vise can move a little bit, but it is mag chucked down. So maybe I put a little too much oil on the mag chuck. Let's see what happens. Okay, so I'm going to enter from the downspin side of the wheel. So we'll turn on I'm going to double check the mag chuck. It's always a good practice. So we're completely on. The stone is above the part to grind. Oh, that's coolant. So we'll turn on our stone here. And if you come in from this side of the stone, if the part jams up and kicks out, it's already leaving the stone. So it's a lot safer to come in from the downspin side of your stone. So I'm going to start to find the first spark, which is there. And then I'll make sure no one else is taller. And then we can start grinding down our ejector pins. I'm going to rough these in first and then get a more specific measurement on the mold that I'm working on. And every now and then I need to make sure that I'm not going below another pin. So now I'm picking up 2 pins. So now I need to start going across to make sure that I'm not leaving any of them out. There's the last pin. There you go. Looks like I need coolant. Alrighty, well now I am going to keep grinding these down. I'm going to adjust the camera a little bit so you guys can see better. I'm going to lock this guy. Now that I'm not focused on one pin, the heat buildup on each pin will be less. Or maybe not. I'd rather not have too much flood with it being so high, because it'll kind of get everywhere. But I think I probably should start with a flood. So I got one hand on the X, moving back and forth, one hand on the Z axis, dropping it down. I'm basically finding the same height for all of these. And then every now and then I'm going to change Y so that I don't run a rut into the stone. Oops, the wrong direction. You kind of sound by, or you tell by the song it sings. There, they're all in contact now. I changed the Y a little bit. Actually, I'll just go across all of them. Excuse the airplane. Okay, let's see what we got. So I'll drop the caliper down. I'll probably wind up measuring on the top of the ejector pin foot. 4.295. 4.295. Okay. We'll go over to the mold and check the height. So I'll be back. So that's a correction. I must have picked up the wrong edge. So here we are at 5.015. All right, so according to my math, I need to take 0.22 inches off of these ejector pins. I guess I was a little generous with the rough cutting with the die grinder. So anyway, let's do some grinding. This should be a little faster. There's our serialized grinding fixture. So thanks for watching. I've got more ejector pins to grind now. All right, talk to you later.